You found the HTML injection. The tag renders, so you start pushing. You try a script tag, and the sanitizer eats it. You try an on-error handler, it eats that too. You put JavaScript colon inside an href. Same thing. Every handler you know dies before it reaches the page. The sanitizer is doing its job, and it is doing it well. So you already know how this ends. HTML injection, no XSS, you file it as low or you drop it because a low isn't worth the time. Now watch this. Same field, same sanitizer. There is no script tag in that payload. No one, no handler, no JavaScript colon, nothing, and allow list would even blink at. And the page just pulled JavaScript off my server and ran it. We have three things today: the primitive and what actually happens when HTML you control lands in a page. It's a lot closer to writing code than you think. Then the gadget, because the primitive on its own does nothing and it's not where you would go looking for it. Then the hunt. 6 steps. One of them takes 10 seconds and kill most targets before you waste an hour on them. And here is the part that changes how you pick targets. The thing that turns this into code execution is not in the application's code. Nobody on the team wrote it. Nobody on the team has a reason to update it. It is just ships with the app. Same gadget and thousands of targets. And today I'm going to show you exactly where it lives. So this is AmrSec. Go get your coffee ready and let's dive in.
The channel has enough content.
As this is
Like, look, download that in You think of HTML as markup, tags, attributes, structure, something the browser draws on a screen. It is also a variable declaration language. Nobody teach it that way. And here is the rule. Put an ID on any HTML element and the browser creates a JavaScript variable for you. The name of that variable is window, dot, and then whatever you typed in the ID. Put a name attribute on the embedded, a form, an image, or an object, and you get the same thing. Window dot whatever that name was. And on images, forms, and embeds, that name reaches the document object too. Hold on to that last one. It comes back later. The browser does this at parse time. You do not opt in. You cannot opt out. So an anchor tag with an ID of X is not just a link, it is an assignment. You never wrote a line of JavaScript and window.x exists anyway. Now here is the line that actually matters. Name the element references resolved before lookups of built-in APIs. Before, not after. Not only if the name happens to be before. That's the spec. Every browser does it because every browser is supposed to. So this is not you can create a global variable. Any injection can create a global. This is you can win a fight against a global that already exists. Think about what already exists. Document.cookie. That's how the page reads its cookies, right? Document.getElement by ID. The application code calls that constantly. Now watch what two tags do to them. An image with the name of cookie. An embed with a name of getElement by ID. Document.cookie stops returning cookies and starts returning your image. Document.getElement by ID stops being a function and starts being your embed. The next line of code that calls it breaks. Look at what you didn't use. No script tags, no event handlers, no JavaScript column, no data URI, no URI schema at all. Nothing executed, not one character of your input train, and the page just lost 2 built-in APIs. 2 tags, that's your primitive. Now let's see how far it stacks. Alright, this is our rollup, and this is Bursh. It is a shared inbox for support teams, and this box right here is the workspace notice. Whatever I put in, it renders straight into that bar at the top of every page. And here we have no sanitizer. So my IDs and my names came out the other side untouched, and this is the only thing this technique needs. Now I'm going to keep using one word, so let me tell you what it means. Levels. A level is one property name I have to control. For example, window.redirect2 is a single name, just redirect to. That's one level. Window.config.url is two names, config and then URL underneath it. That's two levels. So count the names in the read, and that tells you how many tags you need. Now, let me start with the first one, and the first one is only one name to control. So here what I'm gonna do is I will just expand my DevTools a little bit and go here to search. I can do this by hitting Command Options F, or from these three dots, go to search. So here I will search with redirect to, and I hit enter, and you can see here it is in the file sessions-switch.js. And if I click on it, look at this code here. Here is a read out of the app's own JavaScript, window.redirect2, and if it's empty, fall back to /profile. Now look at the search results here. We have 3 hits, and every single one of them reads that value. Nothing in this old app ever sets it. So a developer wrote a default for a value that goes missing basically every time, and goes missing is an invitation. That's one name here, which is redirect2. One name, one level, one tag. So what I'm going to do is I'm going to inject a single anchor tag, and I'm going to give it an ID of redirect2. That ID becomes window.redirect2, which is exactly the variable that read is looking for, and the href on that anchor becomes the value it hands back. So here in this workflow notice, I will just leave everything as is, but when it comes to this anchor tag here, I will just edit a little by adding first an ID, and this will equal redirect2. Okay, and then we have the href, and here in the href I can just pass my URL, which is in that case will be JavaScript colon, so I will add JavaScript colon alert like this. Maybe I can make it alert 1. And that's it. Now before I hit save, I will just remove this so we can notice what's happening, and remove all this text, and then let me remove this as well and click save. And as you can see here, there is nothing fired, but when I go here to switch the workspace, you will see we have an alert 1. And there it is. Nothing executed to put that value there. The tag was the assignment. And yes, I used JavaScript colon in the href because this field has no sanitizer, and it is the fastest way to prove the read landed. Put a sanitizer in front of it and that value changes. The Clobbering does it. Now let's make this 2 names instead of 1 name to control. So here I will hit OK, get back to the workspace, make this any normal text and save to make sure all good. I will be back here to the search, and I will search with something like window.config right here, and you can see we have multiple hits, and all of them is in the runtime-settings.js. So if I click here, you will see we have all of them here. The first one, the second one, third, and fourth. So let's start with this one here. And this one is window.config.url, and it is falling back to javascript.js. So here comes the names. We have config and we have URL. That's 2. So one tag isn't going to do it. And here is the trick. When 2 elements share the same ID, the browser stops handling you a single element. It hands you a collection, and a collection lets you look things up by name. So here what I'm gonna do is I'm going to inject 2 anchor tags. Both of them get an ID of config, and that's what builds the collection. Then on the second one, I add a name of URL, and that's what I look up inside the collection. Its href carried the value. Config comes from the ID, URL comes from the name. 2 names, 2 tags. So what I'm gonna do is I will come back here. I will start with a tag, and this a tag have to hold the ID of config, okay? And then I will close it and declare the a tag as well, and then I will open another a tag which will hold the ID of config as well, and the name of it will equal URL because that's our second name we need to control. And the href here has to be our evil JavaScript file. So I will add something like https 001.com, for example, then /evil.js, okay? And I will close this href, and I will close the a tag, and I will close it here as well. And then I will just click save. And once I click save, I will go to network here and make this visible here and go to advanced. You will see here we have our evil script, which wasn't here before. And if I go to console here and write config, you will see here we have HTML collection of 2. And if I come right here and write config.url and hit enter, you will see it returning my evil JavaScript file. So now we ask the console for config, and it hands us back a collection, not an element. You ask it for config.url, and here is my anchor. And if you look at the panel here, you will see that the app is now telling me its contact widget loads from my own evil domain. Now we cover 2 names down. Let's cover 3 names to control. In the same search here, if I go to the 4th result or the 4th hit here, you will see we have window.config.production.api_url.value. Config production API URL. 3 names, so 3 levels. And I need one more trick to reach that deep. But here it is. A form publishes its own controllers as properties on itself. So an input named API URL sitting inside the form becomes a property of that form. So I'm stacking both tricks now. First, I inject an empty form with an ID of config, and that opens the collection, same as before. Then a second form also with an ID of config, and this one gets the name of prod or production. That's how it becomes config.production inside that collection. And inside the second form, I will put an input with name of API URL. That gives me config.production.api URL. Then I just read the value of the input. So here in the settings workspace notice, I will just remove all of this, and I will start with form, and this form will take the ID of config, and here I will close the form since it is done, and then I will open another form again with the ID of config, and here I will give it a name, which is in that case production, so it will be prod, and then I will close it. Inside the form, I will add an input, and the name of that input will equal API URL, and the value of it, let's say the value is 123, for example. Now I will close the input, and I will close the form as well, like this. Now before I save this, if I go to advanced, you will see that the reporting endpoint is /API. So here I will paste it again, and the value here I added is 123. So once I click save and go to advanced, you will see that the reporting endpoint is now 123. All right. And if I go to console here and write config.production.api URL.value, this will return the value I added, which is 123. And that's basically me added 123 as API URL value nobody thought you could reach. And notice what came back, not an element, a real string straight of the input. That matters more than it looks, and here is why. Here, if I go back to workspace, remove this one, okay, and then save and go to advanced tab, you'll see here we have settings published by the page, and we have here object HTML form element. So watch what happened when I clobber with a div nested. The panel builds that line by gluing config onto the end of some text. So the browser has to run my element into a string, and what it gets back is the text object HTML dev element. And it is junk. The clobbering worked perfectly and the exploit did nothing. Nothing through, nothing logged, no error anywhere. You just sit there wondering why your payload died. So if I come back here to workspace and instead of form, I use an anchor tag and the ID config and add any example JavaScript and click save and go to advanced, you will see here we have a URL. Only two elements turned into something useful when the browser converts them into text, an anchor and a base tag. Both hand user href. So that's the rule. If the code wants a string, you want an anchor or you want the value of an input. Everything else is a dead payload that looks alive. One thing before you go and test this, Firefox does not build that collection. Duplicate an ID there and it hands you the first element. Only the first, so anything built on duplicate IDs can work in Chrome and through in Firefox. Same target, same injection, two different results. Test them both or it didn't happen. 3 payloads, nothing great. You wrote variables into that page with plain markup and the page reads them back as its own. And every one of those would have walked straight through a sanitizer. And that part deserves its own explanation. The sanitizer is not broken. That's the uncomfortable part. It stripped the script tags, it stripped the handlers, it stripped the JavaScript column. It did its whole job, and then it handed the page an assignment statement on the way out. Think about why. IDs and names don't execute. They don't load anything. No script context, no URL, no sync. On a review checklist, they are the two most boring attributes in HTML. So no allow list ever stripped them. Every allow list answers one question. Can this render code? Nobody ever asked whether it can make an assignment because nobody thinks of markup as assignment. The sanitizer answered its question perfectly. The question was wrong. Now, sanitizer did catch on. Anti-clobbering check went in, and those checks are collaborable. Dump-Purify carries an internal check that asks whether a node has been collaborated. It reads a few of that node's own properties, its node name, its set attribute, its child nodes. If any of them hands back an element instead of what it should be, the node is collaborated, and Dump-Purify wants nothing to do with it. That's reasonable. Watch it fail. Hand a form with an event handler on it and put one element inside named after a property that it checks reads. Now the check fires and the node looks collaborated. Dump-Purify tries to remove it and the removal does nothing because that root has no parent to be removed from. Then the attribute cleaning step sees a node already flagged as collaborated and returns early. So nothing ever looks at that event handler. It comes back live. That's real CVE from May this year, fixed in Dump-Purify 3.4.6. You beat the anti-clobbering check by clobbering the anti-clobbering check. And it runs deeper than one library. Any check that asks the DOM about itself gets back the answer you injected. You are not attacking the logic, you are attacking what the logic reads. So you can beat the sanitizer. Now you need the other half. Something has to actually read the global you just created. And there are two places that reader can live. Everything so far used a global the app wrote itself. That gadget is real, but you have to go find it target by target. Now the other kind is the one that's already sitting there before anybody writes a line of application code. And here, if I go back to my console and search it with current script like this, you will see we have here multiple hits. And I will click on the first one. And look at that. First, before we look into that, this is a shipped bundle, not a source code, not a variable. This is what a real visitor downloads. And near the top of almost any single page app, there is a block like this. It's the bundler's runtime, and it has one job I care about. When the app lazy loads a chunk, something has to decide what URL to pull it from. So here, read what it's doing. You find the script that's running right now, takes its source URL, use that as the base path, and honestly, that's a good idea. The bundle knows where it came from, so it knows where its siblings live. That value becomes the bundler's public box. On the screen, it's the ugly one, __webpack require.b. It's the base path for every dynamic import in the app. Now put that next what we just learned. Document.currentScript is a property of the document object, and named elements reach the document object, so currentScript is collaborable by name, and the code wants a source URL of it. An image tag has a source URL. So my payload is one image. I give it a name of currentScript, and that's what it takes over document.currentScript. Then I pointed source at my server, and that's the value the bundler reads. And it will be as simple as going back to the workspace, and here in the workspace, notice what I'm gonna do is just coming here and adding an image, and this image I will give it a name, and the name here is our target, which is current script, and I will close this and I will give it a source, and the source here is our evil JavaScript file. So here it is. I will just close it and close the tag as well. So here we have one tag, no handler, no schema, no script, and one thing before I inject it, because it will save you an afternoon. Dump purify blocks this exact payload. It drops any ID or name that collates with something already on the document object, and currentScript is one of those. Every other payload I showed you still walks straight through it, but most sanitizer in production aren't dump purify. They are an allow list somebody wrote by hand, where ID and name are on the list because anchors and forms need them. And that's it. So I will cut this payload and I will go to conversations here. Let me go to a specific conversation, this one for example, and this is the field I'm going to use, add a play box on a conversation. Watch what it strips and watch what it keeps. So here, if I edit the script, normal script with alert 1, and close the script tag like this, and send the replay, you will see we have nothing here completely. But if I added here an image, and this image gets the source of X to return an error, and on error, I just add like an alert, the same alert, and then close it and click send replay. You will see we have a broken image here, which is pretty cool, but if I click on it, you will see it is only having source, so it stripped the on error thing. So what if I added an anchor tag, and this anchor tag have href of, let's say, JavaScript column, right? So JavaScript and alert 1 like this. I will close it, close the e tag, and now I will just send the replay. You can see here we had the S, and if I hover on it like this, you will see the anchor tag here doesn't have any href at all. But if I come right here and added my payload, which is the image with the name of it, currentScript, and my evil source URL, and click send, you will see we still have a broken image. But if I go back to console here and write document.currentScript and hit enter, you will see here it returned the image. So script tag gone, on error stripped of the image, JavaScript colon dropped of the link, and that means the sanitizer is working. But my payload, it comes through with the name and the source intact, and all you see is a broken image. So here in the console, it returned an image, as you can see, and that property is supposed to be a script element or null. It's neither. So here I will delete these comments because I added the URL without the evil JavaScript file like this, and you can see we have no comments, and I will add the same exact payload, but I will add my JavaScript file, which is reporting.js. Okay, now I will send the replay, come here and run document.current script again to make sure it is here. Now watch what's gonna happen when I go to reporting. I will go to network, and here you can see we only have this file. So let me make this a little bit bigger, go to reporting, and now you can see we have reporting.js here, which came from the evil.amrsec.lab reporting.js, which is the file that I injected. So it is only one tab click, one chunk request, and look at where it went. That's my host with the app's own file name on the end. The app asked its bundler where to get its code, and its bundler read an image tag. And here, if I go to my Docker logs, you will see we have the get to reporting.js on my evil server, and after it, we have post/collected, as you can see here. So my server answers, and the app runs that file on its own chunk. And look at what I can see here. The origin is still AmrSec.lab, not the evil one. So that's the Porsche's session cookie, and that's the account is signed in as. Both derive from the ads on API because my code is running as Porsche. That's not injection anymore, that's delivery. Now check those out. We have this CVE, this one, and this one as well. We have here 3 build tools, 3 teams, and 1 gadget, because all 3 solve the same problem the same sensible way. And let me scroll here to the batch section. You can see here in this one, and in this one as well, and here as well. So the badge is one line. Ask the element what kind of tag it is before you trust its source URL. That's the all fix, all 3 projects. Now, here is the condition that makes it fire. In the webpack config, there is a setting that's called public path. So you set it to auto or never set it at all, and you are in. And by the way, nobody sets it. So nobody switched this on, nobody misconfigured anything. The vulnerable setup is the one where nobody touched the config. That bug doesn't live in the application you are testing. Nobody on that product team wrote a line of it. It lives in the thing that built the application. 8 lines of bundler runtime compiled into the output of the way out of the door. And that changes how fast it goes away. Build tooling sits in a log file on a version nobody has a reason to bump, because bumping it changes nothing anybody can see. So that same gadget is on thousands of targets right now, waiting for one HTML injection. And that answers what I showed you at the start. I never got a script tag through because I never needed one. The app had already shipped the loader. I just told it where to load from. So how do you find this on a real target? You have 6 steps in order. Each one either opens the next or ends the hunt. Step 1. Find markup injection that won't take a script. You already have these. That HTML injection you filled as low and forgot about. The markdown renderer under comments. The profile bio that keeps your bold tags. The SVG uploads. Anything that renders your input into a document somebody else can open. The loudest signal here is a help page that says limited HTML allowed. Somebody built an allow list and nobody ever asked that allow list what can be named. Step 2. Confirm IDs and names survive it. This is the old precondition. If this fails, everything after it is wasted time. Inject that, load the page, open the console and type the value you added. If an element comes back, you are in. If you get undefined, this target is done. Step 2 kills most targets, and that's fine. 10 seconds to save an hour. Take that trade every single time. Step 3. Fingerprint the bundler. Now you are reading build outputs, not application code. A chunk file name buttons, a webpack chunk variable sitting on window, vite markers, and the runtime blob at the top of the main bundle. That blob is not the app. That blob is where gadgets live. Step 4. Search the bundle for current script. Then look at what sits next to it. A tag name with a check besides it means it is batched. Move on. Nothing guarding it. reading the source URL straight off. That's your gadget. It shipped to production, it's minified, and nobody has opened it since the build. Step 5. It checks the app actually lazy loads. The gadget sets the base path for dynamic onboards. No dynamic import, no payoff. Then the network tab. Click through the routes, watch for chunk requests on navigations. If the whole app came down in one bundle, the gadget still fires. It just have nothing to deliver. Step 6. If the bundler already carries the fix, hunt application gadgets instead. Now back to the bundle. Search for reads off the window object with a fallback. Window.something, double pipe, a default. Config objects, feature flags, API-based URLs, anything with a fallback is the same invitation as my first payload. You are just choosing what shows up. 6 steps. 2 of them are a search box. And notice what you never did. You never went looking for a bug in the application. You just fingerprinted the thing that built it. And that's the method. Now the scale, so you know it's worth your week. An automated sweep ran across the top 5,000 sites on the web looking for Clobbering gadgets. It came back with 497 of them, all 0-day, 19 CVEs out of 1 boss. Look at what it hits: Google's Client API, Webpack, Vite, Rollup, Astro, Jupyter, Canvas LMS. Those aren't small projects. That's the software sitting underneath targets you already have in scope. And here is the number that should change how you plan your week. Over 200 of those sites also shipped the HTML injection you would need to reach the gadget. Not one or the other. Both halves, same origin, already live. This is not a lab technique. It is waiting for you to type an ID into a comment box. Now, let's talk about the classic. Gmail's AMB for email, $5,000. The sanitizer was hard-ended, allow list based. It stripped every script, every handler, and every schema it didn't recognize. And only 4 anchor tags beated it. The first 2 flips a pair of internal flags to truthy. The last one hands over a URL, and the page loads whatever script that URL points at. No script tags, no event handler, no JavaScript colon anywhere. 4 anchors straight through the allow list. And it is Chrome only, by the way. That's the collection rule from earlier. Now, the part that decides whether you get paid. Triagers close this as HTML injection, no XSS. One of them has properly done it to you. It is the easiest close in the queue because on paper you injected some markup and nothing bugged. Take that option away from them. You have to show the network requests leaving your host, show the code running on the other side, 2 screenshots back to back, your server logs, then their page executing. Give them nothing to argue with. The finding is not the injection. The finding is the delivery. 3 things to carry out of this. 1. HTML is an assignment statement, and your sanitizer was never asked that question. It answers, can this run code? And the Clobbering never runs anything. 2. The gadget is usually not in the app, it is in the build tooling. 1 gadget, every target that shipped it, and nobody has a reason to bump the version. And 3. The test costs 10 seconds. Inject an ID, open the console, type the name, and if an element comes back, keep going. And that's it. If you found this video helpful, do not forget to like, subscribe, and hit that bell icon for more cybersecurity content. And if you have any questions, feel free to drop them in the comments below, or you can reach me directly on X. Until next time, stay curious and stay secure.